Right. Good afternoon, everyone, wherever you're watching from, at home, in transit, in the office. This is Tech Talk, brought to you by Tech Tribe. And today we're going to be looking at a very exciting topic. We're going to be looking at from ClickOps to GitOps, the rise of observability as code. And with me today is a very dear friend in the industry. His name is Israel Morgan. So it's going to be showing us, practicalizing to us what it is to have the observability as code. So that's what we're going to be doing today. Before I move further, I just want to introduce Israel very well. I will, of course, ask him to also introduce himself. Israel is a software and DevOps engineer, and he specializes in building secure and scalable infrastructure across multiple cloud setups. He has spearheaded initiatives to streamline deployment workflows and also enhance system monitoring. It looks like he's a monitoring guru, if I want to put it that way. And what the work he has done has resulted into quicker releases and also reduced infrastructure downtime. He has over 4 years experience in the cloud and DevOps industry, and he has created solutions ranging from platform engineering and compliance to performance optimization. Israel is passionate about collaborating with teams to implement reliability into every stage of development. So, Israel, welcome to Tech Talk.
All right. Hello everyone. Uh, I hope you can hear me. It's a pleasure to be here. Um, Mr. Olamide has really gassed me up. I hope I can live up to the reputation.
Instead
Um,
of
so
gas
thank
too.
thank you once again.
All
So
right. All right. Thank you. You want to say something, Israel?
oh no. Good. You have the floor.
Okay. Thank you. All right. Everyone. That's Israel. Is going to be is our host. I said the host. Is our guest for today. Is not the host. I'm the one hosting. Is our guest for today, and it's gonna be. I'm very sure. I'm looking forward to this. I've not heard this for the first time. But this is the closest I will be to seeing someone demonstrate how um observability as code works in the site reliability industry. All right. So I'm very eager to also learn, and I'm sure everyone who is watching will also feel the same. Now, before we go into the practicality of what we're doing today, I want us to soften things up so that we don't come too strong. Israel, when did you begin your career in IT, of course, in DevOps or cloud industry itself? When did you begin, and how has the journey been for you?
Thank you for asking, Olamide. I've always been passionate about technology since I was a kid. So I grew up curious and I began coding in my teenage years, I believe somewhere around 17. But it wasn't anything serious. It was just playing around with HTML and CSS. So I don't know if to say that was where my IT career started in. But I think I took it serious somewhere around 2021, 2022. I was in the university at the time. I was on IT specifically. So I interned at a web hosting company, Broad and that's really what kickstarted everything for me. My my boss at the time, he forced me to learn Linux. I did not want to learn Linux. It looked very difficult. It was just I was just used to Windows, as a lot of people are. So I hopped on Linux, and in a short time, I could see the benefits. I could see the trade-offs, and all the fun things one could do with Linux. And I also ventured into software engineering, specifically backend with Node.js and uh, and the cloud too. And that's basically mixing those three things, software engineering, my knowledge of Linux, and the cloud is what birthed my appetite for DevOps in 2023. So I took some certification courses on Amazon, AWS specifically, and basically deep dive into everything. And that's what got the ball rolling. And we're here today.
Yeah, no, that's a good one. The next question I would ask you would be, this is like my wild card question. This is the question I ask almost all professionals I've met. In your 4 years of working in this industry, um, what has been your challenges, right? And how have you been able to overcome it?
I think uh, there's a lot of challenges, especially in this side of the world, as you might be able to relate to Olamide. There's
Yep.
the infrastructure, there's uh, no much support, there's the lack of information, there's just a lot of challenges here. But I think those are the ones that stood out for me. I think mostly knowing what to do, knowing where to go, knowing which door to knock on, knowing what to learn, knowing what to invest your time in was
Mm,
a big challenge for me. And I think what helped with that was basically community, just being in spaces,
mm,
being around people that have trailblazed and being around people that are also in the same category as you, also still finding themselves. Because it always helps having people like you and having people that have gone ahead of you. The mix, I believe, is very important. So that's really one of the biggest solutions to the challenges of information. And then for the infrastructure, as you know, there's issues with internet, issues with power on the side of the world. So there's not always that, there's the willingness, but there's no infrastructure to support that hunger, the drive. So I believe it's just to keep going because there are times where it's going to get really really tough. And the logical thing to do would just be to give up. I mean, you've put in your best. There's just a lot of factors out of your control. But even at that, I think stretching and just reaching beyond and hoping is usually what takes you to the next step. Yeah, thank you, Lamdi.
thank you, thank you, thank you. I wanted to beat what's it called, the topic, but I won't go further. Before we go right into uh before we go right into the subject of today, I just quickly want to for anyone or everyone watching, I quickly want to announce that um the SRA Day, um the London will be taking place on the 24th of September. SRED London will be taking place on the 24th of September. So SRED is always this seems to be the right place to talk about, because you are going to talking about you're going to talking about monitoring and also of course it's going to be a community led event for people working in system reliability, right? And people who are also working in DevOps, and people who, if you do monitor, if you work in the cloud environment, infrastructure as well, it's going to be very suitable event for you if you're trying to keep cloud systems steady. If that is your responsibility in this world of AI, you're trying to keep it steady while AI keeps sneaking into the stack, right? This is an event for you. Again, it comes up. It's September 24, 2026. The location is Everyman Canary Wharf, in London. It's an in-person event. The details are online. You can check the LinkedIn. It's there. if you need a discount, I'm giving out 30% discount. If you need a discount, ping me on LinkedIn at Alamide Koshile, and of course, I'll get your tickets for you with a 30% discount. Now, having said all that, let's go straight to the interesting subject we have today: ClickOps to GitOps, the rise of observability as code. Now, why why observability as code, Israel? Why do you think observability as code is important in the stage we have now in the world of cloud computing or DevOps?
Okay. Thank you for that question, Olamide. So there's um there's this passion, or I wouldn't call it passion, but there's more of a yearning towards automation in our world, in the world of technology. And when you have automation, there's less mistakes, there's less risks, there's less of a lot of human negligence. Not to, no shade on humans, anyways. But it's always better with automation. You know, you can count on automation. You can know that at 7:30 a.m. every day, this is going to happen. You can even set it down to the second that it happens, thanks to automation. And so, observability as code, or everything as code, basically is a step in that direction. You know, with infrastructure and with observability, it's a step towards more automation, knowing that I can say X is X, and no matter what happens, X is going to be X, and there's not going to be any disputes of having uppercase X or lowercase X, or basically any mix up. So I feel with observability as code, the goal here is better automation for the observability stack. We've seen this work out for the infrastructure as code, as if anyone on here is a DevOps, or even if you've been in the space for a while, you would most likely have heard of infrastructure as code. And we saw how that played out. Is being able to provision your resources, whether it's your database, your servers, your instances, whatever it is, using code. Personally, for me, I learned it. Fun fact too, I learned it because I was feeling very lazy. Clicking around on the AWS console was very, very stressful. And when I heard about infrastructure as code, I just had to jump on it, and it was great. You could define the regions you want your resources to be provisioned into, set up the configuration, and a lot of things. Just using code on one screen and typing it out, and you could use this template. You could use the specific templates for multiple projects, and just tweak certain things that you needed to be tweaked. So that this we could see this trend, you know, come to play in the infrastructure realm, and it's something that stuck. It's something that was embraced. There was a lot of adoption for it, and then it popped up in the observability space. With observability is actually the combination of other micro or mini stacks. There's your monitoring or your metrics. There's the logging. There's your tracing. There's alerting and a few others. So once we put them all together, we call it observability. So the goal is to get that flexibility and automation that we had in infrastructure, and bring it over to observability, whether you're trying to define your monitoring or your metrics or your alerting threshold, or which logs should be considered for which, or anything basically to trace, whether you're trying to trace a request from the start to the finish, just being able to define that using code and not having to click around on the dashboard, not having to ask yourself, oh, what was it I did before? Where did I go to before on this dashboard to get certain things done? Because you have a version control using uh, Git or your version control hub, whether it's GitHub or Bitbucket, Argo CD, whichever it is. You have a sort of a memory of previous commits, what your observability stack looked like at a specific period of time. You have the rollback advantages. So you could basically just roll back to a previous version, and there's a lot more advantages that observability offers, as we have seen in infrastructure that also applies to observability. So that is a key. That for me is why I jumped on this and basically shared it because I feel like it's something everyone had to hear, had to know about. Thank you, Olamide.
Yeah, that's a good one. That's a good one. Now let's go to what you haven't prepared. You've prepared for us. I know. I don't want to ask the questions before I demonstrate. Let's go to the technical part of it. So I will allow you to do that, and I will follow up with a few questions if that's okay.
Okay. So am I allowed to share my screen now?
Yes, please go ahead. Um, so if you just click on the all right, I've seen that, and I'm gonna add that to stage. That's good.
Can you please confirm you can see the screen?
Yeah, I can see it. Observability has got yeah.
Okay, lovely. So I basically spoke about this a bit some minutes or seconds ago, and I would like to first just give us an overview of everything. I think we have, by this point, you already know a little bit about me. Uh, AWS solutions architect, somewhat of a community builder. I've gotten the chance to work alongside great companies and apply this knowledge. Um, I also recently earned my Kubernetes Cloud Native Associate certification. So um, that has given me
That's a
experience
good
and
one.
knowledge on the Kubernetes stack. Thank you very much. So the, I planned for the session to last for 5 minutes, and here's basically a breakdown on how we'll spend it. First of all, we'll talk about the problem and the core concept of observability as code. Then we'll move on to the tool chain that we'll be using in this live demo. Then we'll proceed to the actual demo. Then we'll have a wrap up where I drop the links to the GitHub repo and a Q&A session. So without further ado, let's get
I'm
started.
sorry, Israel. Your voice is kind of low.
Oh, noted.
Are you
Is it
able
better
to?
now?
Okay, yeah, far, yeah. That's good. Thank you.
All right,
Perfect.
lovely. Okay, so the problem with they call it ClickOps. Everyone calls it ClickOps at this point. The problem with ClickOps is that first of all, it's made by humans, and it's not exactly a problem that, but there's some underlying factors that can be problematic as time progresses. So the dashboards are built manually. It's not automated, so you basically have to click around and create these things and configure everything. The alert rules can shift, and there's basically no review or history of what was at a certain point of time. So basically, everyone is going with the flow, going based off what they remember, and that's not dependable. There's no way to roll back to a previous version. So if you did something that was not so great, you would have to remember how the previous state was in order to roll back. There's also a tribal knowledge, like I said before, someone has to know these things instead of there being a source of truth. There's no support for, there can be support for multi-environment architecture anyways, but then that's going to involve a lot more manual building. So you'd have to build a dashboard for your dev environment. You now have to build another dashboard, maybe mimicking the first one for your staging environment, and then do the same thing for your production environment. So you can begin to see how manual this can be and how tasking it can be. And then lift and shift can become very tedious. So lift and shift in the sense that if I'm if I create an observability stack for this application and I'm creating another application and I feel like a lot of these components are usable. So just trying to transfer my configuration, whether it's my login configuration or my tracing or my monitoring configurations instead of just being able to copy and paste, it's something I would have to start going again to click around and create these resources. Obviously, referencing what I have previously, but then again, it's still somewhat tedious. So these are just a few problems that we can cite in the ClickOps um, ClickOps format of provisioning your observability. Uh, so as you can see, there's a lot of holes in the current, or should I say, the outgoing way of provisioning your observability stack. And then came the birth of observability as code, as we discussed earlier. So observability as code is this flexible tool where you can configure your dashboards and everything basically using code, not having to click around your user interface and basically just write out what you want using your YAML file or your JSON file. You deploy it, your observability stacks the machines or containers that are running these images can read off these configurations that you have provided and do what they're supposed to do and visualize what they're supposed to look like. That's basically the entire idea behind observability as code, as we have seen with infrastructure as code. So you can store this configuration in Git, which is a version control tool. You can basically have sort of state of time reference to what your configuration was at each point in time. You can always review it. So, for example, I ask an intern or junior developer to update the configurations. He can update it, and then I, as the manager or the senior engineer, can review these configurations before finally deploying them to production. So there's that extra step of safety. There's also the automation aspect. So if it is with code, we can automate it. Can automate it using a push pipeline like GitHub Actions or Argo CD. Just anything that enables us that once we're able to update our configuration, uh, um, run our git push command, the pipeline picks it up and updates the dashboard with the new configuration. Then finally, your UI, whatever you define in the code, is exactly as it is on the UI. So that's these are this is the idea behind observability as code. Um, okay, so for this example, and I mentioned this earlier, that observability was basically a mesh of different substats like uh, monitoring, tracing, logging, alerting. It was a mesh of all of these to be called observability. You know? So this for this demo and for this meeting, we'll be talking mostly of monitoring. So the monitoring stack basically encompasses your time series data. The idea behind it is to tell you when something happened. So it's basically going to tell you at this point in time, this was how this was how many requests that hit your app. At this point in time, this was your CPU capacity. At this point in time, this much traffic ended up on this endpoint URL. That's basically what the monitoring or the metrics stack is about. Like I said before, it's under the observability stack generally. So there's a couple of tools you can use for monitoring in your environment, but the preferred tool currently is Prometheus. So Prometheus basically scrapes the data of what's happening and when it's happening, and then feeds it to Grafana. Grafana is basically just a UI tool. It's there to visualize the data that's being stored and read off Prometheus, and that's the flow. So behind Prometheus and Grafana, you have your node exporter. The node exporter is basically what's pumping your data from your architecture for your system, whether it's a server. It's pumping the data of what's happening at when and feeding to Prometheus. Prometheus is analyzing it and basically storing it and processing this data into readable formats for Grafana to visualize. So I believe I said most of the things on this specific slide. So I'm just going to skip to the next one, but that's the flow. Your node exporter exports the data, you're monitoring data. Prometheus analyzes this data, receives this data, and then pushes it to Grafana for visualization. So Grafana is just there as a UI tool. Prometheus is the one doing the underlying work, and also node exporter. Node exporter is just pushing this data to Prometheus for it to be able to analyze it. Okay, so that's the flow. Node exporter, Prometheus, then visualizing Grafana. At this point, I think it would be a good idea to have a live demo just to show us all um, about how it looks like and how it works in practice. But before then, I would like to explain what we're going to do so we are all kept abreast. So in Prometheus or in monitoring generally, if you're using Grafana as the visualization tool, you're going to have several dashboards. You can have several dashboards anyway. If you want to have one or multiple, you can do that. You can create more than one Grafana dashboard. You can create dashboards for different things entirely. Some of them strictly based off your system, and then some of them specifically for your application. So, for example, you have a server, and on this server, you're running a Node.js application, right? So you can create a dashboard for your server that basically reads the monitoring and the metrics of your server itself. And you can create another dashboard that reads the metrics of your application that runs on your server. I hope you understand the analogy. So you can have multiple dashboards. It's really up to you, or you could have one dashboard. So each dashboard would have a segment, as we would soon see. So each dashboard is going to have a segment, and inside these segments are called panels. So the panels are the configurations that you basically write on what you want to visualize. It could be the CPU, it could be the memory, it could be the load if it's on your application, it could be the traffic to a specific endpoint. So these panels are like the dashboard is the mom basically, and then the panels are the kids. They are the ones that specify the the metrics for specific scenarios. Like I mentioned earlier. So they basically specify this is for your CPU, this is for your memory, and the entire thing is wrapped in the mother, which is the dashboard. So that's what we're going to see in a short bit. So that's the relationship between the dashboards and the panels. Next up, we'll be using Git and GitHub for this demo. So as I mentioned earlier, observability as code is um, makes use of Git, Git control, makes use of version control rather. And for this, we're going to use Git. So Git is basically keeping track of what our code is like at every point in time, every time we commit and push to whichever is our preferred hub. For this demo, it's GitHub. So we push to GitHub. Um, if you're familiar with GitHub, you understand what I'm saying. There's a lot of version control, seeing what the state of your code was like at all points in time. So that's the use of Git and GitHub. So if we want to roll back our dashboard to a previous state, we can easily do that with our um, our Git commit. So we're using Git for our version control, and we'll be pushing to GitHub. And finally, I set up a server for this demo. I set up an EC2 instance on AWS. So it's a small instance which we're going to be using for the demo. I set up Prometheus and Grafana and also Node Exporter on the um, on the server. I believe I should be able to show that to us. So I did that using Docker because this is a even if it was a permanent thing, it's advisable to containerize your applications. Using Docker makes you faster. You can always pull a specific image depending on what you want. But if you've worked with containers, you would understand what I mean. So if I Docker PS basically shows us which containers are currently running on our application. And in case you're wondering, all of these steps are in the GitHub repo for this project, which I'll be leading on chat soon at the end of the demo. So if I run Docker PS, it shows us which containers are running at the moment. And as you can see, there are three containers running, my Prometheus, my Grafana, and my node exporter. And I explained the use of each of these. Okay? So the Prometheus analyzes your metrics and your monitoring data. Grafana visualizes it, and node exporter basically exports the data to your Prometheus. Just had to go over that once again. So I have these three components running on my EC2 instance, and this is basically a terminal, but it's powered by AWS. You know, it's easier, so I don't have to use my own terminal, my local terminal, or a terminal software to do it. So I could just easily connect with this AWS. I believe it's called uh, Console Client Connect, or something around that. But if you have an instance running on AWS, it's an option that you could use to connect to it. So I'm connected via SSH basically, and you can see what's on my server. It's basically just I'm just going to go down to the uh, parents folder, and you can see it's basically just one folder named OAC, and I pulled this folder from my GitHub. I feel like I should delete this so we could basically start afresh. Okay, so if I run the list command again, there's nothing on it, but my containers should still be working. You can see the containers should still be working. So my containers are all up, configured with Docker. There is no configuration file on the system at the moment, and we'll get to that just in a bit. So the first step you want to do is to create these configuration files. I created some earlier on, and I'll explain the folder structure, right? So right here we have our Grafana and our Prometheus folders. Um, we also have the Docker Compose folder. I believe that would be a good start. So if you've worked with Docker, then you know Docker Compose is used to run multiple containers at the same time instead of having to run each Docker file separately. You could just configure each of them in one file using Docker Compose. So as you can see on my Docker Compose file, I have node exporter image, I have the Prometheus image, and I have the Grafana image. And each of these are set to use, I set them to use the latest tag. You can set them to use a specific tag. Uh, it's basically your preference. So I have each of them set to use their respective tags. I've named the containers, each of them node exporter, Prometheus, etc. And you can see here on the server, the container names are exactly the way I set them up on the Docker Compose file, right? And I have assigned them ports that they can use for my Prometheus. It's um, exporting at port 1990. Grafana can be read on port 3000, as you can see here. Uh, my node exporter is on port 9100, as you can see here. So they all have their respective ports in which they are going to run on. And a few of them have volumes, like my Prometheus. Prometheus has a couple of volumes which it uses to store the data that it's receiving from the node exporter. Grafana is also running a volume, a Docker volume, and these volumes are not permanent. I made them ephemeral, temporary, since it's just a demo. But if you were on a live, well, I still believe you could make them temporary. But if you want to make them permanent, then you'd have to go that extra step of creating a Docker volume and configuring it in a way that it can withstand a restart. All right, so this is my Docker Compose file. It's set to run three images, node exporter, Prometheus, and Grafana. It's going to run these containers on their respective ports. Let's get into the observability, or in this demo, the monitoring or metrics configuration. So for my Grafana, I have two folders, the dashboards and the data source. So the dashboard is basically, as I explained later, is like the mom, and then the panels are going to be under it, and you'll see that in a bit. So for my dashboard, I created just one dashboard, which is named the demo dashboard, but I think we can call this something more interesting. Uh, yeah, let's call it the Tech Tribe demo dashboards. Um, we specify the type file, and each of this, just so it doesn't look like I'm pulling these things out of the air, there is a documentation for it. Grafana has a documentation on how to build a dashboard using a YAML
So you
file.
just, okay.
Come again?
I said you just
Can you hear me?
copy and paste.
Yeah, so you could
Yeah, I
just
can hear you.
copy and
So I said
paste,
you
and
just copy and paste, then modify
yeah,
to
copy
suit yourself.
paste. Exactly. Thank you very much, Olamide. So there's a documentation, and I've added the links to the repo, which I'll share in a bit, or Olamide will help me share. So you could just copy and see the configuration. It's not like we are pulling these things out of thin air. So for the dashboard, this is basically the name of the dashboard. We're going to call it the Tech Tribe demo dashboard. It has an ID. It's not a folder. It's just a file. And then we provision the path for getting here, basically. That's for Grafana. And then this is the this is basically the panels that I mentioned before. So this is going to read off the dashboards, and then have configurations for each of the panels. And this is the name of the dashboards: OAC demo, node metrics, and then you're going to have tags. If you've worked in the cloud, or if you've worked with Kubernetes, then you would know the use of a tag. It's if you want to give some extra identity to a component, you can add tags aside the names. If you worked on the cloud or with Kubernetes, then you'd understand this better. But it's just one of those things. There's nothing too special about it. And for our time zone, because observability deals with not observability anyways, but metrics and monitoring deals with time. So I want to know what happened and when it happened. So the when is obviously going to be time related, and I need to set a time zone for that. And I feel like it's a good idea to set it to use the browser's native time zone that it's using. Then we have a refresh time set. We also have schema version, and these are just basic configurations, you know, for the Grafana dashboard, and then we get to define the panels. So like I said before, the dashboard is the parents, basically the mom, and then the panels are the kids. So you can see each panel is going to have its own scope, basically. So for the first panel, give it an ID, and then give it a title. So this is going to capture the CPU usage on this server. Okay, so it's going to read as a time series data. These are specifications of what the UI, the representation of that of this panel should look like. Its data source is set to Prometheus. Remember, we named the Prometheus container Prometheus, and then it also has targets, is basically set to read the CPU usage from Prometheus. Okay, and then we have another panel here. This is where this panel ends. We have another panel. You can see it has an ID set to 2. It has a title. This is for memory usage, basically. Remember the grid parts. This is to specify the representation of this um, this panel. And just hang on a minute, you'll be able to see what these look like on the product end. So it has a data source, the same thing set to Prometheus. And if you can see the difference here, the targets are different. Like I said before, this targets uh, the memory basically because we're trying to capture memory usage. So it captures the node memory usage, right? That's what its target is. And then this panel's target is for CPU. So this captures the CPU usage, as you can see, CPU in seconds. So the first panel, CPU, the second panel, memory usage. And this is it for the dashboards. Okay. Still on Grafana though. We have the data source. So in this file, we're going to configure where Grafana reads the data from. And Grafana, if you remember when I said it's when I described the flow, it's node exporter exporting the data, Prometheus analyzing it, and then Grafana reading the data of Prometheus. So Grafana is going to be getting this data from Prometheus. We've described uh, the container. We've named the container the Prometheus container Prometheus, so it's easy for our Docker network to identify it. We also have the URL. If you recall, Prometheus is running on port 1990. Grafana is running on port 3000. Node Exporter is running on port 9100. So we've set the URL to read off this port, and then this is basically yet again. I'm going to say there's a documentation for this. You could just go there and see the configuration on the Grafana documentation, official documentation website, where you can basically copy, paste, and configure these things and understand how they work. So this is it for Grafana. Here we have Prometheus. We have Prometheus alerts. We won't be working with alerts for this demo. Um, there won't be enough time to basically configure this, but I hope you can see there's space for having Prometheus alerts. We can configure an alert for a high CPU usage or high memory usage or anything for or high traffic even. But we have that flexibility even when we are using just code without having to click around the dashboards. We can do all of that using code, and that's the beautiful thing about observability as code. And on the Prometheus configurations, you can see it scrapes the data of, like I said, node exporter feeds this data to Prometheus, and then Prometheus basically analyzes it, works on it, and then sends it to Grafana. So this is basically what the configuration is saying. Node exporter on port 9100, and then sets the targets to the Prometheus port. So this is the very slim architecture we'll be using for this demo. You can see Prometheus configured to read from uh, Node Exporter, Grafana to read from Prometheus after the data has been analyzed. And this is basically it. I've reviewed the Docker Compose example. So you're going to so we've seen this already. Well, one final thing I think I would like to tweak this. I believe it was the JSON, yeah, to tweak this to match. Uh, all right. So we're just going to be creating one dashboard. Again, I would like to remind us we can create multiple dashboards with multiple panels under them. Okay, so uh, all we have to do now at this point is deploy these updates to our GitHub, and then we are going to pull these updates on our server, and we start our containers to read with the updates that we have currently. And just to show, I believe it's a good idea to show what's currently on there. I was basically making an example earlier on before we hopped on the webinar. So this is currently what was running before. This is the name of the dashboard. This is Grafana, by the way. Uh, I don't want to have to start from here. Let's just start from the welcome page, the home page, right? Okay, so this is Grafana, right? As we log into it, there's usually a login option, but since I logged in, I've already logged in. But once we redeploy, it's going to restart and I'm going to have to log in again. Yeah. So just on the home page, you can see it already shows us the dashboards that we have. I can click on the dashboard that I created earlier on. And as you can see, there's basically um, just two panels running, right? There's the CPU usage and there's the memory, like we did earlier. So just to add to this and to show us the power of OAC, let's go back and add one more panel. And for that, I already created the file and stored the configuration on it. So I'm just going to copy this and paste it, then explain what it does exactly. So if I paste this in under the dashboards and the node dashboards with JSON, this is just an extra panel. So I'm going to put that under the panel, the next panel after this one. Okay, this is this is basically going to read the system load. So you can see we set the ID to 3. The title of this panel is system load, and just if you look back at this for reference, there's just two panels under this dashboard, right? CPU and memory. So adding the third one, uh, this is going to calculate, calibrate, and tell us more about the system load. You can see the targets are reading uh, differently from the first two. They are set to read specifically the load that's on our server's node. Like if you remember before, I showed you these. This is supposed to read the memory, and this is supposed to read the CPU usage. So this is going to read the load that's currently on our server node, and the grid pods are basically the representation. The grid pods are this configuration that we see here, how the axes are drawn, the horizontal to the vertical. I'm trying to recall the right word to use it. I can't recall now, but I hope you understand what I'm saying. The virtual, the visual representation of how this panel is going to look. This is a panel, by the way. This is another panel as you would sure know by now. So the grid pods is basically the configuration for this panel. So having added this extra panel to it, I could go ahead and commit and push this to GitHub. I'll pull the update on the server and show you how it changes. So, okay, so now we've pushed to our GitHub repository. I already set up GitHub on, apologies, I already set up Git on the server. So as you can see, Git is set up here. So I'm just going to have to, you can see Git is set up. So I'll just have to clone that repository, and I dropped the repository link on this document just so I can reference it easily. And I'm going to leave us with these links, like I said before. So if I clone this on here, and I list to see the folders on here, it's been cloned from my GitHub. If we enter the folder and list what's inside, we can see it's the same. It's the same folder, it's the same project as I have on my local, you know, the same thing from Grafana to Prometheus, my Docker Compose file and my README file. This is everything present here. So I'm just going to go ahead and restart my Docker files because the Docker files have been configured to, apologies, my Docker containers. My Docker containers have been configured to read off these folders, off these um, they've been configured to read off this Docker Compose file, which in turn points to the configuration on the Prometheus and the Grafana, like I showed us earlier. So if I go ahead and Docker Compose restart, okay, and we can see here again, If I refresh this, everything's still the same. So until I update it, and if you remember earlier when I mentioned automation, yeah, I could basically set up a GitHub pipeline to handle this automation, so that once I push from my local um, computer, the GitHub pipeline picks it up and triggers an update. So it's going to trigger a restart on my server. Yeah. So that's an option. If you're using Argo CD on a Kubernetes cluster, you can do the same. It happens automatically. Once you push, it basically pulls that update and runs it. So I could have set up a GitHub pipeline, GitHub Actions basically, and the pipeline deploys this update immediately I push it. But for the sake of this demo and to keep things as simple as can be, I'm going to restart this, restart my containers with these new configurations, and you'll be able to see that they have updated. And even after now, I would go ahead and make one or two other changes to the panel, and then just basically do a git pull from my server and also restart it again. So you can see how the flow is and how flexible this architecture is. So if I go back to and I think I forgot to mention this part. So how did I get to my Grafana UI, right? It's basically running the IP address of my server. Yeah, you can see it's HTTP, so it's local. Nothing has been launched. It's just the server IP address, and then mapped to the port of Grafana. If you remember, I said Grafana
Yeah.
runs on port 3000, and it's
Good.
it's all in the configuration
Yeah.
on the Docker Compass. Sorry, that skipped my mind. So that's how I was able to reach that dashboard. So uh, if I run this again, I'm going to get a prompt to, okay, interesting. Okay, maybe because I already logged in and the volumes are still running. Okay, well, as you can see now, first of all, you can notice the first change. The name of our dashboard has been changed to Tech Tribe
And,
OAC Demo. Right, so if I click it, you can see there's an extra panel, the one we added called System Load. You know, our CPU usage and our memory usage panels are still up because we left them in the configuration. And this is simply observability as code. So imagine if you wanted to replicate this architecture on another project, I could easily just clone the repository, you know, deploy it on that server, make some tweaks if I have to,
mm,
and boom, I have it running. So this is the flexibility that comes with it. You can make any changes you want, and it's going to be the same thing. If we choose to tweak the name again, I just want to show us that we can do it with a git pull, just a simple git pull, and um, let's do let's just add let's just add one word at the end, so you can see. So I'm just going to commit this to. Okay, so if I push this to the GitHub repository, I simply come to my server. Now, this is simple SSH yet again. Simply come here and I just have to pull from origin and it's going to pull the updates, right? And in order for me to see the the updates I've pulled and it's all still the same. So it's going to be like this until I restart it. I remember you could easily automate this with a GitHub Actions or anything, any other, or a Jenkins pipeline or any other automation tool. Just a friendly reminder. So if I restart this again, we'll be able to see this updates that we made to the title. Voila. I'll just have to refresh that again. I don't think I've refreshed the page yet. And everything is back to the way it was with our updates on it. So this is the flow, this is the flexibility, these are the pros that come with using observability and defining your observability stack with code. and not having to click around and manually provision things. So there's the automation, there's the version control, and many other pros to it. Like I said, lift and shift. For me, that's the best. The fact that I can just scoop this, put in another project, and continue where I stopped this. It's awesome. So
It's a,
I
that's
believe
that's good.
this is the end of the live
That's
demo.
that's uh, that's time well spent. It
Thank you
looks
very much.
like you asked it. Right, yeah. So I just have a few questions for you, or if you remember the question. The first question would be the place of AI assisted observability. From your experience as someone who has worked in DevOps and you work a lot with observability tools and all. Where do you think AI assisted observability tools existed? What do you think? What role do you think they will play in the long run?
Okay, I think AI in observability is actually a for me a very important part of it because the observability is it's a very important aspect, right? But it's secondary to the actual application running. So you can't have the observability stack running without first having the actual application or the server running. So it's a secondary thing, right? So AI is able to help us with uh, a lot of things. For example, the configuration aspect. You could see the coordinates for the grid pods, those visualizations and all of that. We don't, as humans, we don't have to actively memorize these things. We could assign this for AI to basically create the visuals, to create the configurations, and then we could just stick to the variables that actually matter to defining what we want to see on our stack. So it basically just scrapes away this layer of manual labor, for lack of better words, that could have done. So basically, the AI could build the observability house, right? And then we get to define what it should look like, what it should house, what the inside should look like, and what it should do. So it's that man and machine type of partnership, in my opinion.
All right, no, that's good. Because of the time mentioned that we do not spend more than 1 hour today. As you were uh, doing the hands-on experience, I was thinking of something bigger. I hope you will have time to do that in the future when we can build from the real infrastructure, a demo infrastructure, and I mean a full stack observability as well integrated
Sorry,
into
I think
it.
I
Sorry,
lost you there. I don't know
can
if
you
you
hear
can
me?
hear me.
Yeah, I can hear you now, and I can hear you now. I think we lost
Okay,
each
I
other for a few
can't
seconds.
actually
So,
hear
so
you.
as I was
Give
saying,
me a second.
can you hear me now? All right. Waiting for. Can you hear me, sure?
My apologies. My
Right.
alarm came on and it just told me
Okay.
to come off.
Is it better now?
Yeah, it's better now. I can hear you clearly.
All right. Yeah, we're rounding up already. Thank you so much for your time. It's really appreciate, and these are the things we do for the community, right? Where
It's
people
my pleasure.
can learn from people who have I mean, a practical hands-on experience. This is not just a YouTube. It's not just a YouTube tutorial. Something applicable. So thank you so much, Israel. So I was saying before the internet dropped. I was saying I'm hoping I'm hoping that in the nearest future we can come and I mean dedicate more time into uh, talking about observability at large, right? As far as infrastructure, cloud infrastructure is concerned, and do a hand-to-hand demo. I mean, building a real-life infrastructure, all right? Real servers with real workload. are running and see how observability works and how observability and codes can be utilized to make our observability more effective. So, thank you again, Israel. Of course, the way I jumped on you on your LinkedIn, I'm very
No problem. No problem.
I'm very pleased. I appreciate that you made the time out to be here today to contribute your own quota to the community. So, well, thank you again. Thank you for everyone watching. This will be the end. Unfortunately, we can't go past 1 hour today. So, this is Israel, the Israel organ. You can, if you have any question, or if you're curious to know more about observability, please go to his LinkedIn profile. You'll find in the Israel organ, and you can ask him any question. Right, and for the repo for this demo, everything will be included as a description, all the necessary information, including his LinkedIn profile as well, will be included in the description on the YouTube. So I will get all that sorted for everyone. If you also have any question again, if you can't get across to him directly, you can also speak to me. So thank you again, everyone who has joined, who is watching from everywhere you're watching from. My name is Olamide Koshile, and our guest is Israel Organ.
Oh, it's been my pleasure. Thank
Uh,
you for
do
having
you,
me,
you
Ola.
want to say goodbye? Yeah.
Yeah, definitely. Thanks
You're
for having me,
welcome.
everyone.
Right.
Thank you. Thanks for having me.
Mm, yeah. Thank you. Bye, everyone.